Good afternoon. It's good to see so many people in the room. My name is Michael Amstelveen. I'm part of the system engineering team within Arista in the Netherlands. I'm here today with my colleague Herman Baan and Robert van der Starre, who's responsible for the sales in the Netherlands. I'm going to talk about running VXLAN over, or IPstack over in VXLAN Fabric, actually. VXLAN seems to be very hot nowadays. A lot of people are using it as well for data center interconnect. But today we're going to focus in on running OpenStack over a VXLAN Fabric. So let's first touch base on the motivation for VXLAN. The most famous one is the 4K VLAN limitation, which you have because of the 12-bit. You can allocate only 4K VLANs, and in some larger data centers, people need more than 4K VLANs. Hence the introduction of VXLAN, which has a VNI field of 24 bits, which gives you up to 16 million unique tenant IDs. The other thing VXLAN is solving is the need to have, large core switches which can hold a lot of TCAM because you will need to store all the VM's MAC addresses. If it's in the case of layer 2 network, you need to store all these MAC addresses in the core switches as well. If you move to a VXLAN fabric, you basically have an IP core. You no longer need these MAC addresses. And it shouldn't be a surprise that, in general, a layer 3 fabric scales much further than any layer 2 network in the world, right? Because a layer 2 network has certain limitations. Think of your broadcast domain and so on. The other great thing about VXLAN is that, let's assume you have a traditional layer 3 fabric, right? You can go and plug in some top-of-rack switches, leaf switches, which supports VXLAN, and run VXLAN across your IP fabric. So there's no intelligence required in your core to support VXLAN. And then bottom line is that nowadays most of the network ASICs are supporting VXLAN encapsulation in hardware. So the first ASIC from Broadcom, which was the Trident 2, I believe released in 2013, was the first ASIC which basically supports hardware encapsulation. The most recent one, Tomahawk, of course, also supports VXLAN hardware. So, anyone familiar with VXLAN, by the way? Cool. So let's do a quick sort of refresher, right? So assume this simple topology. You've got a host on the left-hand side connected to a switch, which then connects to a IP fabric, and then connect to another switch, which connects the other host. So these hosts, assume they are in the same subnet. There's no way these guys can communicate over a layer 3 fabric. So what VXLAN basically does for you, it basically allows you to transport your layer 2 network over a layer 3 fabric in order to provide you layer 2 connectivity. So a couple of new terms we need to talk about. One of them is a VTAP. So VTAP is a virtual tunnel endpoint, which is basically the starting point and ending point of your VXLAN tunnel. I specify a dotted line because it's not really it is stateless, right? It's a UDP packet, which actually that's the next slide. I'll talk about it in a bit. The other thing we need to talk about is a VNI, something called a VNI, which is a virtual network identifier, also sometimes called as the service provider tag. So you've got the customer tag, which is VLAN 10, and then a VNI, which is basically used in the core of the network to identify this specific customer. So let's assume host 1 is going to communicate with host 2. A packet hits a switch, which is a VTAP, which will do the encapsulation for you into a VXLAN packet. This VXLAN packet then is put on a wire on your IP fabric, and it hits the destination VTAP. This is the egress VTAP, and it will do the de-encapsulation of the VXLAN packet and strip the VXLAN header and push the original frame onto VLAN 10. Once it's has stripped the frame, it's going to do a layer 2 lookup, and it knows where to go. So how does the actual packet looks like? This is the VXLAN header. It's 50 or 54 bytes big, depending whether you're using .1q or not. And then you got the original frame. So there are a couple of things we need to talk about, right? So with VXLAN, there are different ways to do the... A very good question, and I should have mentioned this. So this is point-to-point, but VXLAN supports point-to-multipoint as well. Thank you for the question. We will cover this. By the way, I have 2 books to give away, Arista Warriors. I don't have them with me here, but they're downstairs on the booth. So I'm going to make sure you're going to get one of these books. So with VXLAN, you have a couple of ways to learn, in the control plane to do the signaling for your bomb traffic. So you've got IP multicast, which is as per the RFC 7348, head-end replication, or you can use something like Arista Cloud Vision together or without a third-party controller. So let's have a look at the multicast control plane, right? So assume you have this network with 4 top-of-rack switches connected to an ESXi host. The ESXi host has a couple of VMs in there, VM 1 to 4. They're all in the same subnet. Let's assume VM 2 wants to talk to VM 4. So VM 2 is going to send out an ARP broadcast. It's going to hit the VTAP. The VTAP is then going to do a encapsulation of the original packet into a VXLAN packet, in this case with the destination multicast address, and it's going to be flooded to all your VTAPs. So one of the requirements with if you're using PIM is that, or IP multicast, that you will have to enable PIM in your network. Now, we've seen a lot of pushback from different customers saying that, yeah, okay, multicast might be a great, or PIM might be a great protocol, but we don't want to enable it just to run multicast. So in that case, I mean, this is one of the options. And because of that reason, we basically thought, what other options do we have? Just to finish off, this is how the configuration would look like. On the VTAP, you specify a multicast group. You have the source interface. In this way, you do the mapping between VLAN 10 and VNI 10,000 in this case. So let's have a look how it would work in a case where you're doing head-end replication. Same thing, let's say VM2 wants to talk to VM4. It's going to send out an ARP broadcast. The VTAP is going to do the replication for you, and it's going to generate 4 unicast packets to each VTAP. Hence, the packets hits the VTAP, and then the VTAP will do the de-encapsulation for you. And then in this case, the returning traffic obviously will go back as a unicast because we've learned the MAC address of this source in this VTAP. How would this configuration look like? Basically, you specify 4 or 3, your neighbor VTAPs. Now, some of you might sit there and say, okay, but this is cool, but it acts, it requires a lot of configuration, and this works in small environment, but once you start growing, it's going to become, it might become a challenge. So to solve that issue, we basically have something called Cloud Vision. Cloud Vision is a framework, and for today, I'm going to focus on the CVX part, which is the a sort of marketplace for your information. So in this case, you connect your orchestrator or your overlay controllers. Instead of ask them to talk to all your switches in the network, you only ask them to talk to CVX, which is available in an ASA cluster. And then CVX will talk via an API towards all your switches. So in that case, the configuration is much simpler, right? Because CVX or the controller will have a list of all your VTAPs. Hence, you don't specify anything like, okay, these are my VTAPs. And when it comes to the packet flow, you're going to have the same thing, that this guy will now have a dynamically learned list of VTAPs where to send the packet to. We're here today for OpenStack, so I'm sure most of you guys are aware of the modular layer 2 plugin, which is a core plugin from Neutron, which was released in the Havana release. And with that, basically, we have a mechanism driver, what they called, to speak to CVX. So I've built this topology to make it more, realistic for you guys. Instead of doing a live demo, which is going to be really hard to do with the mic, I took some screen captures, but this is the topology. You've got 2 spine switches and 2 leaf switches. Just for fun, I've created 2 different BGP ASs. And the idea is that I'm going to take you step by step in how we integrate with OpenStack and how we basically can establish end-to-end connectivity over a layer 3 fabric using VXLAN. The first thing you want to do is you're going to create a tenant. So you either use your CLI or you use Horizon. ML2, oh, this is screwed up there. ML2 will basically send an API call to CVX. And now on Arista switch, you can see that if you do a show tenant, you notice that the tenant is created for you. Next thing what you're going to do is you're going to create a network. Again, in CVX, you can do a show OpenStack network tenant, and it will tell you that a tenant name was indeed created. You could also do this on the CLI if you like. So a couple of interesting things here is that this VLAN ID is something you specify in your local conf file, right, in OpenStack. So I'm using devstack. So in the devstack, you basically specify a range of VLANs which you can use for provisioning. So this is something you specify in this local conf file. I have an example for you later. What you also see is that it automatically maps you this VLAN ID to this VNI ID. Now this mapping is something you specify on CVX or an Arista switch. Any questions so far? Now the other step you do basically is that you create a couple of instances where you going to connect these instances to the network you just created. In my case, I'm going to create 4 instances, which then going to be connected to the network. So again, this shows you the integration we have. So if you do a show OpenStack VMs, it's going to tell you exactly which VMs are behind, on which host, and also the network you sort of bind it to. Now, a great thing which our customers really appreciate is assume you have a issue, you need to find behind which switch or which port a certain instance is sitting. You could issue a single command to find out, show OpenStack physical network, and then the name of the OpenStack host to tell you that, I know now that Hadoop 1 is sitting behind leaf switch 2, Ethernet 4, right? So CVX basically has a broad view of your network and the intelligence of the network. So know exactly which VM is sitting. Very useful for troubleshooting. I don't know if you've noticed, but so far I haven't touched the switch, right? I did the configuration for the switch once, but for the provisioning I haven't done anything. So this basically shows you that we dynamically create a VLAN on the top of rack switch, which is required for these 4 nodes. So this is the top of rack switch leaf 1. And remember, we had 2 OpenStack hosts behind it, and they're sitting behind port Ethernet 3 and Ethernet 4. Now, because we spin up an instance there, the mechanism driver will talk to CVX, which will then provision our switches for us. So far I haven't done anything myself. The other thing, if you think about Mac learning, so Mac learning is like a normal switch, right? The packet comes in and it goes out, and then you basically know that, hey, now I know that this MAC address is behind this port. It works similar with VXLAN as well. So once you start sending traffic across, you will find out that if you do a show VXLAN address table, it will tell you exactly behind which VTAP a certain MAC address is, which VLAN it is in, and on which port.
operation, or is it if you do a show run, do you see it?
That's a good question. So the question is, does it really put the config in the config? You won't see it in the show run. You will see it in the show VLAN that a dynamic VLAN is created for you.
Alright, so there is an application running on the switch that is getting the information from the external controller.
Correct. Correct, because remember, right, so it's a very good question, by the way. So the question here is that once this VLAN is created on the switch, will it basically store it in the config? It will not, because what if it's stored in the config, right? Someone might come in and hey, I no longer need this instance, I'm going to drop it, and then you still have the config there. So what will happen? Let's say the switch, you upgrade the switch, so you reboot the switch, it will come back up. And because you have this connection, it will create this VLAN again for you. So it's a dynamic thing.
Can you also put in static mechanisms?
You could. What would be the use case for that?
Silent host, one server, whatever, who doesn't tell on the
Right. Yeah. So the question is indeed, can you add static MAC addresses? You could definitely have static MAC addresses indeed on the port if you like. Yeah. But you could use other things like S-flow or port mirroring if you would like to steer traffic, or you can use things like OpenFlow or direct flow if you want to steer, intercept certain packets to send to a specific tooling server. Any other questions?
How about the integration of the ESX switch, E-switch or D-switch? Because you just indicated that the switch can learn where VLANs reside. And how do you do that if you're able to read out the ESX configuration?
Right.
How does it then work?
So the question is, what about a VMware or ESX environment? So the same integration we have and visibility we create for you guys with OpenStack we have with VMware, whether it's NSX or basically what we do is via an API call we talk to vCenter to learn about which VMs are available, and then we do the correlation for you. So you could do a show VM tracer Ethernet 4, and it will tell you which VMs are behind this port and what the status is of these VMs, whether they're up or down, which VLAN they're in. But that's not part of something we are covering today. Although these are static slide guys, we have a live demo downstairs. So if you're interested in any of these integrations, you can come by and we will show you guys the live demo.
Maybe also off topic, but you showed on an earlier slide the partner of Nuage. But Nuage, the solution, as far as I understand, depends on their own VLAN, right? They have their own vSwitch that is a VLAN. How is the integration?
So the integration we have with Nuage is sort of similar in the sense that there are videos online and white papers available regarding the integration. But the idea is that you dynamically, once you provision something in Nuage, it's going to provision our switches as well for the right, ports, VLAN. And
But the VRS component of Nuage is a VLAN.
right. So all good questions, guys. So just let me park it for now. I'll get back to you. So ultimately, this is what we have provisioned so far, right? So basically, we had the leaf spine architecture. We spinned up 4 VMs. They got an IP address in this subnet, VLAN 500. Remember the port Ethernet 3 and Ethernet 4. And the next step is to show you guys that we have connectivity between these hosts, right? So I logged onto the OpenStack Neutron server, and I list the IP address, and then via the namespace, I connect to Hadoop 1, and from there on, I was able to ping all the 3 different, so I SSH to here, and I was able to ping this guy, which is obvious, nothing fancy there, right? But then I was also able to ping these guys, which basically showed that we are crossing a layer 3 fabric using VXLAN. There are a couple of...
Michael, is that a
A trace route?
If you do a repeated trace route, you see the IP nodes, but do you have some similar for VXLAN?
So the question is, do we have a something like a trace route for VXLAN? From what I remember, it is something that we're working on. Herman, you have any? Can you confirm? Okay.
Well, for VMware, we have integration with ESX. We have that. It was called NSX Tracer. But for OpenStack, that is something we are in regular VXLAN we're working on. It's not available yet.
It is not something we have available today, but if you're interested, I can see if we can get some, some sort of examples how it's going to look like. But it definitely makes a lot of sense, so that's why we have it. So just to show you guys another cool thing is what you can do on our switches is that you can run a TCP dump. And basically what I did while I was pinging across, I was running a TCP dump on the switch on the Ethernet 1 port, matching the VXLAN packets. And you could basically see that the green colored text is the VXLAN header, which has obviously the source destination MAC address. And then it has the source destination IP, which are the VTAP IPs basically. So these are the loopback addresses. And then you can see that it's port 4789. And it also shows you the VNI. Now, one of the things you need to be aware of, right? By default, once a packet is encapsulated into a VXLAN packet, there are two things you should be aware of. One is that your VLAN ID is by default stripped. So you don't see the original customer VLAN ID in this trace, because it's no longer there. Instead, it's replaced by VNI 500. If you want to do this, you could run .1Q tunnel over VXLAN, which then will have your VLAN tunnel in there. The red text is basically the original packet, right? Which is an ICMP request. In our case, going from the original VM IP to the destination VM. I don't know if you've paid attention to the latency here, but this is not really in line with Arista's hardware, because we're famous because of our low latency. So it's time for convention. But basically, what I did is that this is all running on a hypervisor. So we have our OS called EOS, Extensible Operating System, but we have a VEOS version of as well. So it's basically the actual software, but we strip the hardware drivers to talk to the ASICs, which you basically can use to simulate this. You can use it to validate your design. You can use it to validate a software. You can use it to write your developments against. So pretty good. And then just the running config, right, for your interest. So this is the interface Ethernet 3 and 4. This is all you configured on the hypervisor interfaces towards the OpenStack nodes, and this is the configuration for VXLAN. I've mentioned the VLAN to VNI mapping, which is the VLAN range, which you specify in your local config file. In this case, I was using the ML3 plugin as well. I don't know if some of you are not aware of Arista, so just a quick, 1-2 slides about Arista. Sorry. Yeah, so the question is, do you need to configure BGP? You definitely need to configure BGP. But the way I basically provision this network is using zero-touch provisioning, and then we've used Ansible to provision the BGP for us. We can go in more details if you like downstairs.
You need to configure your own IP layer 3.
Absolutely. You do have to. You need a layer 3 fabric. So quickly about Arista, we are we've been around for more than 10 years now. Shipped over 5 million ports, and we're founded, in 2004 already. Started shipping in 2008. We are on the stock exchanges as well for those who are interested, so you can see all our figures there. What do? We make switches, right? So we've got the smaller switch is a 24-port switch. The bigger switch is a 8-slots RU, which can hold 96 times 100 gig interfaces in there. And the beauty of it, 256 times 100 gig, unbelievable. Wow. And the beauty of it, it has a single OS, which means we have a single operating system running on the smaller switch. You can download it on the website, and you can run it on the bigger switch if you like. Just to wrap up, VXLAN is cool. Make sure you find out whether you want to use hardware VTAPs, coming back to your point, or use software VTAPs. Right? There is a sort of a penalty there which you will pay for performance. We have a strong focus on OpenStack. We're coming with the Ironic integration. It's already available, obviously not in the general release. It's going to be in Liberty. And we also have the layer 2 gateway for those who have bare metal servers who need, So on a bare metal server, you can't have VXLAN in your hypervisor. So in that case, you need to serve a switch which can do the hardware encapsulation. As I've mentioned, VEOS is available. You need to create a guest account, and you can download it, you can play around with it. That brings me to the end of the presentation. Thank you for your time, and have a wonderful day.